Welcome to the Arithmetic Zone, and welcome to what is potentially our final episode of the Simple Java series. In this tutorial, we're going to go over the concept of recursion. While recursion can have a variety of meanings depending on the context and its application, for the purpose of this video, recursion is essentially when a method calls on itself. And when a method calls on itself, that is a form of repetition. So when you have a recursive method, inside of that method is a call to that exact method. So it's essentially going to repeat. And when you have these recursive methods, there's usually a base case in the form of an if statement that checks to see if a certain condition is met. And when that condition is met, that's when that method terminates. So we're going to see an example of that right now. Alright, so over here in my recursion methods file in class, I made a method called digits. It's a void method and it takes a single integer parameter. Because this is a static method, in our main method, we can just reference the class name recursion methods without having to create an object of the class and then write dot digits and then our number. And in this case, I chose 1, 2, 3, 4. So essentially the point of this method is to print out the digits of this number backwards. And the way it works, as you can see, first thing it checks is if the number is greater than 0, and it's going to print out num mod 10, which is the ones digit. So if I were to pass 1, 2, 3, 4, so let me just run the code, it would first print out 4 because that's the ones digit. Then right here, this is the recursive call. I'm calling the exact same method digits again, but this time I'm taking the number and dividing it by 10. So, and when you divide a integer by another integer in Java, then the result is also an integer. The decimal doesn't get counted. So dividing by 10 essentially just cuts off the ones digit completely. So now we have 1, 2, 3 in here. So now we're going to run this digits method with 1, 2, 3. Num is still greater than 0. It's going to print out the ones digit. This time it's 3. And then it's going to call the digits method this time by cutting off the 3. So 1, 2. It's going to once again check to see if it's greater than 0, which it is. Prints out the 2. And then it does it with 1. 1 is greater than 0. It's going to print out the 1 because 1 mod 10 is just 1. First number is less than the second number. That's how modular division works. And once you print out the 1, it's going to go back here. 1 divided by 10, well, that's going to be 0. And then 0 fails this condition because 0 is not greater than 0. And that is our base case. That's when the method terminates. So that seems a little hard to understand at first, but this is honestly one of the simplest recursive methods that I could think of. What if I wanted to print out the digits the other way? So I start with 1 and then I end at 4. Well, let's see. Alright, so I rewrote my digits method into a new method called digits reverse. This one, if I were to pass the number 1, 2, 3, 4, should start with the digit 1 and then print out 2, 3, and then 4. And if you look at them closely, you can see that the only difference is that I just switched the order of these two lines right here. So in the original method, I printed out the digit and then I made the recursive call. But in this method, I'm making the recursive call first and then I'm printing out the digit. So what gives? If I were to test the code, I can see that it does work. It prints out 1, 2, 3, 4 in that order. Well, let's investigate this a little more. When we pass 1, 2, 3, 4 to this parameter right here, it's going to check this if condition. It is greater than 0. Alright, then it's going to call digits reverse on 1, 2, 3. Okay, so 1, 2, 3 passes that. Now it's going to call digits reverse on 12. And then it's going to call digits reverse again on 1. And then once it calls digits reverse on 0, it fails this condition. So, and in that time where we just called the digits reverse method like 4 or 5 times, it has not printed out a single digit yet. And that's because every time we come across this recursive call, the code restarts this method, and then once it finds that base case, it goes back to where it started from, the most recent recursive call. And the most recent recursive call was doing it on 1. That's why it prints out the 1 first, and then it prints out the next recent call, 2, then 3, then 4. So again, recursion, definitely a difficult concept to wrap your head around. It can be really hard to find the specific pattern, find the specific base case. When writing these recursive methods, make sure you always have a base case. Make sure you always have a condition so that Java knows when to terminate. Otherwise, you're dealing with a potential infinite loop or an error that occurs during runtime. So if I were to just remove this if condition right here, if I were to run that method, well, looks like I got either an infinite loop or a runtime error. I'm just going to press Ctrl C so that definitively stops it. And look at all these errors that occurred. So always have a base case. Always make sure that your recursive method has a means of stopping. And any recursive method you can make, it can be written without recursion. So you can just use regular iteration using for loops, while loops, or whatnot. Now I want to get into other methods that we can use with recursion. So these are common methods that you may encounter or you may need to write, and they all involve recursion somehow. So here I have a factorial method. Now I briefly covered factorials in a video a while back. The link to that video is in the description if you need to know what a factorial is and how they work. But if you do know how they work, essentially right here we have two base cases. We're checking if number is equal to 0 or 1, because 0 factorial and 1 factorial are both equal to 1. And otherwise, what we're going to do is we're going to return the number that's passed as a parameter and then multiply by 1 less than that number factorial, because that is how factorials work. 4 factorial is just 4 times 3 factorial. 3 factorial is just 3 times 2 factorial. That's the pattern. And that is our recursive call right here. Notice I am using a non-void method. This method is going to return an integer. So instead of printing out digits, this is going to return a number. So right here, I'm printing out recursion methods.factorial, and I'm using 4 as my example. And the reason why this works, so let me just run the code first. So 24 works. Reason why it works, if I pass 4 here, 4 does not trigger this statement right here, so it's going to go here. It's going to return 4 times factorial 3. If I do factorial 3 is just going to return 3 times factorial 2. Factorial 2 is going to return 2 times factorial 1, and then factorial 1 itself returns 1. So if you think about it, it returns 1 times 2 times 3 times 4, which is equal to 24. Here we have another method. This is a reverse string. Essentially, it takes a string, str, and it prints out that string, but it prints it out in reverse. Now, we can easily just do this with a for loop, but let's try using recursion. So, in my example, I'm going to pass the string ABC into this method. So if I were to print it out, I get CBA, so I know that it works as intended. And as usual, let's analyze this. When I pass ABC right here, our base case, it's checking if the length is equal to 1. So if it's just a single character, single letter, it just returns the string itself. Well, ABC is 3 characters long, so don't gotta worry about that right now. Here we have our recursive call in our else statement. It's gonna return reverse string, and it's gonna call it on the same string, but it's gonna start from the second letter. So it's going to get rid of the A. So essentially it's saying reverse string BC. And then we're adding that recursive call. We're adding at the end the letter that we just removed using .substring 0, 1. So it's calling reverse string BC, and then we're adding plus A at the end. When we call BC, it's not going to activate this, and then it's going to return reverse string C plus B. So B gets added on. So after that, now that the str.length is equal to 1, it's going to return str, which is C. Now we already added B and A at the end, and we added it right here. The order really matters. That's how we're able to get this string in reverse. Let's say I wrote it the other way around. So I say return str.substring 0, 1, and then I do reverse string and then str.substring 1. If I were to do that, then we get ABC. And well, that's what we started with, so this is literally a useless method. The order really matters. I'm adding the letter I just removed at the end with this statement right here. So make sure when you're dealing with these recursive calls, you're really looking at the order of your code statements. Are you having the right content being appended at the beginning or the end? Are you having your lines in the correct order? Make sure you check that. Here we have a slightly more complicated recursive method. It's called count2. So this takes two parameters. It takes an integer array and an index value. And what it does is that it goes through the array and it counts how many times the number 2 appears in that array. Again, this can easily be accomplished with a regular iterative method, but we're going to use recursion here. So in my main method, I made this integer array right here. And if you count the number of 2s, so it appears 3 times. So if I were to call this method, it should return the integer 3. And notice I'm starting from the index 0 so that I cover the entire list. Index is used as my base case right here because I'm going to keep adding 1 to the index and I'm going to check if it reaches the same length of the array. And then it's going to return 0, which is just going to tell it to stop. So I'm going to run the code. I get the number 3, which is correct. Because if I were to pass this array in the index 0, it's going to come to this else statement. And I actually have another selection segment going on right here. It's checking if that specific element at that index is equal to 2. If it is, we're returning 1, and then we're going to call the method again, but then we're going to increase the index by 1. If it doesn't equal 2, then we're going to do the same thing. We're just going to call the method again and add 1 to the index. So essentially check the next element, but we're not adding the number 1 because it doesn't match with 2. And then when it reaches the end, it's just 0. So it's just going to add 0 to the total, which is nothing. And because 2 appears 3 times in this array, this segment right here is going to activate 3 times. It's going to add 1 3 times while checking the next element each time. And that's how that method works. Finally, we got a little interesting method right here. Another method that returns an integer. But what this does is that it returns a Fibonacci number. Now, if you've never heard of the Fibonacci sequence, essentially it's a specific sequence of numbers where the first number is 0, the second number is 1. And then after that, the next number is the sum of the last 2 terms. So if you start with 0 and 1, that means the third number is 1 because 0 plus 1 is 1. The fourth number is 2 because 1 plus 1 is 2. Next number is 3 because 2 plus 1 is 3. Next number is 5 because 3 plus 2 is 5. And the next number is 8 and so on. So when you're dealing with the Fibonacci sequence, because you have technically 2 set numbers, 0 and 1, you're going to need 2 different base cases right here. I have an if and an else if right here. And it returns 0 and it returns 1. If the specific number I'm requesting, if that number in the sequence is 0, 1, it's going to return those numbers. Otherwise, it's going to return these 2 recursive calls right here where I just call the same method, but I check the number before and then the number before that, and then I'm just adding the last 2 numbers. So if I were to write Fibonacci and then call it with the number 5 and run that, I get the number 5. Let's see why. Well, if I were to use 5, alright, it's going to return Fibonacci 4 and then 3. And then when I do 4 and 3, both of those are going to activate these, and then it's going to keep going. It's going to keep calling these methods until it reaches the 0 and the 1. And then because I'm adding the last 2 terms like that, it's going to add up to the number 5. If I were to do 6, I should get the number 8, and I do. So this one's a little hard to explain, but if you see the actual Fibonacci sequence, you can definitely understand. And with that out of the way, that is officially going to be the end of this video. And that, for now, is going to be the end of the Simple Java series, unless I decide I need another video like I did with basic JavaScript a couple months ago. I do believe though that as of now, if you take all the Simple Java videos and put them together, watch them all, that I think you can get a pretty basic understanding of the Java coding language, and you have enough language to learn new things from there. After all, this is just a basic introduction to Java, much like how I gave a basic introduction to JavaScript and web design all those months prior. Anyway, I hope you guys all have a lovely day.